Good afternoon, good morning, good afternoon, and good evening to all the participants according to your time zone. Welcome to Simply Learn. Hopefully, you are all able to hear me loud and clear. So, today we will be discussing about our next session. Our today's session. Okay, so Uday, I think most probably tomorrow you can enjoy your break. Okay, just a minute, participants, before we begin. I just made a little bit of adjustment today. I just asked the team to create a way to share the screen as for the time being, as you know that the Google Drive is not accessible. Okay, and so what I did here is I just uploaded the web scraping code. I think nobody has viewed it. I shared in the chat window. Okay, can you just follow this link? And this is on your code part, so you can simply download this. Okay, it will be a zip file. Hopefully, I will expect that all of you know how to deal with the zip file. Okay, you can unzip this and you will find your Jupyter notebook that we will be discussing now. And I have quick confirmation if you are able to see it. So you can just simply extract here. This is a zip file, nothing much. Inside the zip file, you will find all your three Jupyter notebooks that I'll be using for today. So you don't have to worry about the code, as you can just simply upload this and you can start working on it. So yes, you have to upload this part definitely. Are you all able to see it? Participants, confirmations, please. You can see only one person view here. Speed up and follow the URL link, and it will be redirecting you to this particular zip file. And through the zip file, just download it and unzip it. Just simply click on it. As you will click on it, it will automatically start downloading. After you finish downloading, unzip the file. Once you unzip the file, you can upload this in your Jupyter notebook. Done? Yes, all the participants, could you just please confirm, and if you are not able to do it, then you can also tell me. I'll help you. This is all done so that you don't have to wait for coding, right? I feel like you all... Yeah, sure. Wait a second. What I did here is that in spite of sharing the code in the chat, which is a bit complicated process, and what you can do is you can just simply follow this URL link. And yes, you have to log in through your, obviously you have to log in by your official mail ID that you have been using for accessing your LMS as well, the same URL. The link the email ID that you have used to access your LMS, the same you can use to access this community link as well. So yes, you have to do the login. And once you have logged in successfully, then you can simply open this web scraping zip file, unzip the file, and then you will see inside that how many files you are able to see. 3 files: web scraping assignment, web scraping project 1, project 2, project 1 and project 2, right? You all know how to use this Jupyter notebook file. If in case nobody knows it, if anybody doesn't know, then it is just gonna show you like how to use it. Localhost. It will not open with double click, right? You have to upload here. Click on upload, and then just look for file. Like suppose this is my file, right? Or you are able to see the screen? You all are able to see the screen, right? So you have to click on upload, then click on DS Codes Web Scraping, and you'll find your assignment. You'll find your project 1, project 2. So let's say, for example, you wanted to work on assignment 1. So you'll simply click on open and your assignment one will be opened. Okay. Done, everybody? So just open first. The first part is your assignment 1 that we'll be using. This is the first file that I'll be using. Hey, wait. This is the first. I think I gave you some small file or what. Anyway, at least the code sharing is made easy here. Done, everybody. Let me share you the URL once again. What happened today, being the last day, should be more participants. You should be all time. All anyway. I'll just reshare the URL link. Just a little bit. We can just use this URL link. Follow the URL link. Once you have followed the link, you can simply upload this data in your Jupyter notebook. Then only you can access. Okay. Otherwise, you don't expect to double click over the file. It is a Jupyter notebook, so you have to first click on upload here, and then choose your Jupyter notebook file. That's what the basic thing is. Simply you can open it by the help of open. Once you have opened it, then you can start running it line by line. Are we ready? Yes, participants, those who have joined late, did you understood what are we doing? Can I have confirmation from everybody? What I did here is I created a zip file of all the codes. Please follow all this. Please follow the URL, download the zip file, download all your code, and upload it in your home page. Once you will upload this Jupyter notebook in your home page, you can simply access it. And I request all the participants to now change, you can easily change your send to option to all participants. Because as I'm not sharing any code today, as there is no need to share the code, so no need to send the chat in private. Okay, are we ready to move ahead then? Hopefully all of you have understood what are we supposed to do. Okay, let's get started. So this is our last week discussion. That's where we have ended up our meeting, taking up page.txt, data science, Python, chapter number 11. There is one more chapter which is left after this, chapter number 12. Learn project. In the web scraping part, you can see that we are having this part already we have covered. Yeah. So this is where our things are. Parser part. So these are all about related to the commands, the various commands that you can use. First is your HTML parser. HTML parser is your Python based, and this we'll be using it to particularly parse the HTML file. Shall we get started with this? Hopefully everybody has understood this part. Okay. So as you can see in this case, that you have seen the HTML, right? How does your HTML looks like? HTML looks like a tree, correct? There will be at the top various tags will be there, HTML, correct? It starts with an HTML and then it ends with an HTML. Then this is further divided into head part, which is done by your head. Under the head, now this is your heading, obviously. Heading of web page. Inside the head, there are other things we can add, like title, title of the web page. Meta will be your meta information, metadata. If you wanted to add meta information, metadata. And then we are having body tag. Inside the body tag, you write the entire details about what is the look and feel of your website should be there, right? In the HTML, the current that we use is HTML5, correct? This is the latest HTML that we use. The first is your body tag, and all your major portion of the code is inside the body tag only. Inside the body tag. This is a separate portion. So here only headings and all you add. So head starts and then head ends here. But body part will contain a lot of things which include your subheading. Right, this is your subheading of web page. Like H1. H1 is the highest heading, right? It goes from H1 to H7. Similarly, what is the use of P tag? P tag is important. What is the use of P tag, anybody? P tag is for paragraph. Paragraph tag, correct? Okay, great. Could anybody please share the URL link in the chat, the link to access the code? I think few of the participants has joined late. Anyone? Uday, can you please share the URL link? Okay, thanks Swapnil for doing this. Okay, this is our paragraph tag. Next is UL. What is UL for? Unordered list. Very good. UL is for unordered list. You can have ordered list as well, right? You can have ordered list, you can have unordered list. Like this is basically gonna create the bullets here. The OL is also there, correct? UL is also there. Inside the paragraph, there is a tag. Why these tags are important and why it is important to understand the tree? So the point is your beautiful Sue actually does nothing but it scans, it find all tags to access the data. To access the data. Suppose I wanted to find all the headings present in my HTML page. So what I will scan the, let's say, H tag. Okay, I'll scan for H tag. Then sometimes the data is also under the div tag division. So in that case, we have to scan the div tag, and inside the div tag, there could be a possibility that it will be present inside some class name. So whatever the class name will be there, that will be also fine. That will be also scanned. And we all done it by the help of we do all these things by find all or by using find function. Either we do it like this or we do it by find all. In order to fetch the information, Beautiful Soup target these tags. That's why I'm discussing unordered list. Then li stands for li stands for list item. List item, correct? List item element or simple list item. So this is your item list which is present in our, this will be your items which are present as a list. Yes. What is A tag is used for? See, A tag is part of your, A tag is part of your paragraph. Whenever you create, let's say, suppose I'm having a hyperlink, I created a hyperlink. Hyperlink will be what? Hyperlink will be, say, HTTP, or maybe I can just write here, A will be equals to A href equals to, we write www.simplylearn.com, correct? A href equals to www.simplylearn.com, and then you write, this is your URL. This is your URL. And that's where the aref is used for. This is the utility of A. Okay? So this defines your hyperlink here. That's what the A is used for here. This is your organized data, organized HTML. Starts with a doc type, HTML tag, division or section. Inside the division, we are having our UL tag, li tag, again division tag. Just now you can see that inside the, you can use to fetch the data, either you can use tags or you can scan the information by using class name. You can use any one of these, either tag name or the class name you can use. Fine. So let's say, for example, I wanted to access this data. I wanted to access this data, HR manager. This is inside the, I wanted to access this information, right? This is the data. So this is under your class HR manager. So I'll use HR manager here. I'll use class equals to, I'll just search for where is the HR manager. As you will scan for HR manager, you will get all your information from here. Information about Jack 101, Darren 65, etc. Okay. If you will write ID equals to HR, then inside that you will get these tags as well. It's all about like choosing the correct tag so that you can only target the information and extra tags will be not appear on the screen. Fine. All right. So that's how the things are. Now there is one more thing that you have to discuss is about the parent is Beautiful Soup. So when you read any data, you first create a soup, right? Soup is your all HTML codes. Then you pick your direct child. Okay. Under this child, we are having siblings. What is a sibling here? Sibling could be used to, sibling is also part of the functions here which is provided to us, and through the siblings you can access the sibling part. Okay, sibling part will be accessible by using dot sibling. I'll show you through the code how we can access it. So let's go to the code part to understand it better. How does these things work? For the time being, let me give you a quick things that we are trying to target here. What we are trying to target here to fetch the data from healthcare in Europe, right? That was the URL. Okay. Now from this, we requested, now with the help of request, what are we trying to do? We are trying to fetch all the data, okay, which is done. Then we'll use soup, which will give you the page content using your HTML parser. For HTML data, you will be having HTML.parser. For XML data, you will use XML.parser, which is part of the Python code to get the source web page content. And this particular thing is called a soup, or you can call it as parent, the entire thing. Fine. Now, once we have taken all this data, I use .prettify, which basically converts your unformatted HTML page into a formatted format. And when you use print function around, you can easily see the various, you can see all your code getting present here. The entire code is present. Okay. Code is already been given to you. Hopefully, all of you are able to access it. So I don't have to share the code for this particular example. You can directly download it from the link that I provided, and you can easily upload it. Everybody understood how to upload the code, right? In the home page, there is an upload button. Follow the link, download the zip file, unzip it. There is an upload button. Click on upload and access your code. And then you can simply start running it. So you don't have to write, you don't have to worry about the syntaxes. If okay, so everybody ready? Shall I run? Your first code is uploaded. Let me ask quickly with everybody. Your first code is uploaded, everybody. So I'm gonna start working. So now first we need to access the table data. The first part that we have to discuss here is that we need to access the table data. From all this entire information, I think in your case it is given by r.text type HSC. HSC is there. Now let us try to follow the same link. I'll also follow the same. Okay. So after you execute this, let's take our web page, which will be given by URL lib2 dot URL open. This works with the Python 3 only. Okay, for Python 2 we have got URL lib2 part. Obviously Python 2 is no more present now. Officially it is not there. But still, old days I'm talking about. This is our web page dot read lines. This is my list of the data, where list of the entire information. So let's iterate through for line in our web page. line equals to typecasting dot r strip row strip. Now in this web page we have to search. So RE stands for regular expression, which is used for searching the data. What are we trying to search? We are trying to search which will have a match with table class. Only that information I need to fetch. To lst.append, take your line. Something must be wrong. Let me check. Just a minute now. This is going on some other way. r.text. This is okay. URL lib2.url open URL. HTML page web page dot read lines LST for line in HTML. Okay, this is the wrong one. HTML page. Then we search and let's take the data. Thing is again wrong here. str line dot r strip if re dot search table class comma line lst dot append. We have to append the line. What happened here? RE is not defined. RE will be import RE. Display the LST part. This is all about your table information. Okay, this is all about your table information. Everything is there in the code now. Everything is there. Which particular markdown? This one. Take it anyhow. Every information is available in your given program. I'll be using the same. So first we have accessibility to the table here. This is all about my table. Now from this table we need to, from this, sorry, in file up to print there for me. No, you will be having, did you downloaded the data from the link that I provided it to the participants? So there will be having all the code, not only just this but the other codes as well. You have to just access it and look how I'm working on this data. That's it. Code part you can take it from there. Okay. So we have got the LST part. Now once we have displayed the LST here, this is all my data that has been taken by scanning table class. Right. This is our table class as you can observe. And from here we will be taking up all my data, all my information. Once we have taken all my information from here, this is not the readable format, right? This is not the readable data that we are having. Now we have to look for, see, table class has been taken. Table class has been taken. So we are just simply using a regular expression in this case from Python code to match with the data where table class is present. Even I am not getting Uday Kuren, what are you trying to do? You have uploaded that, then you will see the entire code. Which particular code you are talking about? Scrapping. This is the code name. Web scrapping simply learn assignment number 1. Let's check. This is the assignment 2. How the code is not there? Everything is there only. I think you are not taking that code. I think something is wrong. I've already re-verified it. The same code only. Web scrapping assignment number 1. Somebody share the URL link with him. I think there is some wrong here. You have to use the URL link here that I have uploaded, and I think I have explained it, I think, already 7-8 times. This is the notebook. From here you have to download. From here. I'm asking all of you to follow the notebooks from here. Speed up, guys. This was the code I am asking you to upload. This is the code from this web zip file. You were there when I was explaining this part, right? So you follow this zip file, unzip it, and once you finish unzip part, then you will see the code. The code will look like this. Web scrap assignment part. This assignment you have to upload, and then no. I think something is wrong. You are following some other URL. That is your old code. The new code name is web scrapping simply learn assignment. And in assignment part, the entire code part is there. The file name will be web scraping simply on assignment 1, not web scraping assignment 1. Check it again in the zip file. Others are able to access it, right? Other participants, you are able to see the code, right? The entire code. Can I have a quick yes in the chat? Okay, great. So now we have this all data here available to us. These are all my information. LST is giving you all the data here, which are matching with table class. Now I was explaining about this code here. What are we trying to do? We are trying to read first the entire HTML page. Then we are scanning for each line from this. And from each line we are looking to find those lines where our match is equals to table class. Wherever the table class is matched, only that particular line we wanted to fetch. And this is where we are taking the use of regular expression. Alright. So once you have took here all this part, any other question in this case? Once you have taken all the data, this will be the size of the list. This will be the size of the list. Now that we have taken all my data that matches my class equals to table class. Now we are good to move ahead and let's read the, let us particularly scan the entire data and apply the find function. So from here we will scrap the first table and use index 0 in your LST to capture the first table name, and now read the table using beautiful soup using find function. A simple option is to type the table name. You can simply select the name in the LST. LST is your data, which in this case is your wiki table. So we'll now scrap the information. The best thing is that you can use the table name. This is the table name here. Wiki table, float right short table. That's the table, that's the first table that we are using. So let's use here table. Table will be equals to HSE dot find. HSE is your beautiful soup data or soup data, and that's why it will give you the access to find function. With the help of find function, we can scan our table. Inside this table tag, we have got class, and the class name is wikifloat sort table. So what are we trying to access here? We are trying to access find table tag or scan. Find your scan find table tag. Also scan class equals to wiki table. Okay. So after this we will get only the table part. I'm just sending you the description part. You can attach it to your code so that you can remember. So find function is used to find for this. Now let's take our table. Let's see what is the result here. This is all your table information. Now you can see the extra information is gone. and only the table information is available to us. So country and their ranking, correct? This was our targeted data, and other tags are not important. That's the use of find function, and that's why you have to be very sure about that what is a table and what is your class name inside the table. If you know that, or tags in fact inside the HTML tag, what is a tag name and what is a class name. Once you have taken all this information from there, you can actually find your entire table data. Okay, done till here. You have executed it, hopefully. So let me ask to him his name. Uday Kiran, did you able to find all your code now, the new code inside the zip file? Uday Kiran, did you able to find? Okay, great. Now it will be good to read the header and row names separately so that we can create a data frame. Now in this home page, what we are using, the URL that you are using here, this has got the first table. This is your first table, so we took the first table here. And now from this table, our expectation is to fetch the rows and columns from this. Okay, and the table heading, then the table tags are there. Okay, table data, table records, all these we have to take with the help of our different tags which is used in the coding. Code is available to us. This is my code. Table heading is there, th, right? Table heading, all the table headings are there, which could be my column name. Then what is td? What is the meaning of td? TD tag, anybody? Cell element, table cell element, correct. TD stands for table cell element or table data cell element. Table data cell element. So let's use this to fetch the data so that we can convert this into a nice data frame. So let's read the headers. Let's read the So in this case, what we'll do is we will write here headers. Headers equals to list of headers dot text for header in table dot find all table heading. Display your headers. Headers are world rank, EU rank, country, life expectancy, at birth rate, years. This is my information that is available to us. These are all my information. Now, as you can see that in this case, all done. Till here, hopefully everybody might have completed it. Now let's do the next part. Don't try to run entire code, okay? Let's do line by line so that you will able to focus on understanding and then run the code till headers. So the expectation was to take the header part, and once we have eliminated the headers, you can see that we are left with these header names. We are left with the header names. Now, in this case, you can see that we are having some information like /n is there. So how to remove. Now this is an extra code. I just realized that it has got /n. So sometimes /n/t, okay, or sometimes /p will be also there, or ampersand. These type of values are there, and other noisy tags are there. So we use here string method sstript sstript to is used to eliminate the unwanted characters. Is used to eliminate unwanted characters like these part. So from the headers we need to scan. So I'll just take a code here and this I'll fit it. Itself headers dot sstrip \n for headers in header, and I'll be saving it inside my headers on itself. So now you can see that this is clean. This part you have to add. This part you have to add. Now you can see that your header is clean. Added. This part please add in between, because after your header you will see \n. It is important to clean the data. So in order to clean that, we can use here simply this \n. We can eliminate it. And this is how your value will be eliminated. Now once we have eliminated the data, which includes World Bank, EU rank, World rank, EU rank, country life expectancy, and birth rate years. Now the next part is about related to taking the table rows entry, and TD is for your table cells. So and also in this case we have to use encode, right? UTF-8. UTF-8 is the standard for Unicode value. UTF-8 encoding is used in order to encode your data. Okay, your variable characters will be there. That needs to be converted into a Unicode text, especially when it comes to web pages. And that's the most used encoding. Okay, UTF-9 is there, but UTF-8 is the most used encoding value. All right, so once we have used it, we will be having all my rows will be fetched. So first we fetch the columns, and now we fetch the rows entry, that is the cell. Once we have taken all the cells, let's try to simply merge it as a data frame. So pd.dataFrame, our rows have been already fetched and it is appended into this list part. And what are we finding this time? TR. TR tag will be find, and inside the TR we are scanning for TD. So inside each TR, the TD tag will be scanned, and whatever is stored inside that, it will be stored inside your rows. And then you can convert your rows into a data frame. That's it. Display your data frame, and this is how your information is available to you now. Now from here again you can see that, okay, one more part. I think from the rows also we need to do the same thing. This is also a list. Let's see. Okay, it is list of list. Now from inside the list we need to go, okay, list of list. Okay, let's just do it later. For the time being, we need to just keep on doing the things. So today is the last day, so we need to do a lot of things as well. For the time being, you can see that these n will be there. We can eliminate it by using our furthermore values here. There could be different ways of doing it. I mean, as I said, we need to go inside the list of lists to eliminate this number. Let's not write the code right now. Okay. But yes, what is important here is that what is the use of all these web scraping is to fetch the information which we are able to fetch. The first row is obviously useless, so you can eliminate this. It is coming out to be none. So what you can do is you can simply remove that particular value. Okay, that's one thing here. And apart from that, you can eliminate this particular value. Wherever the missing value is there, you can just do df1 dot drop na access equals to 0, and you can write here in place equals to true. So your unwanted element will be gone and you will be left with only those entries which are available for the Europe. So that's your clean information which is available to us. There are other ways as well which are been explained below. You can follow the same method. It is also one of the similar ways. These are additional things. So using the same method, you can fetch for other data as well. The additional processing steps or additional processing information are also available to us. Like you can create a pre-processing function in order to target your data, and you can eliminate, you can clean your data with the help of this. Like we have got this function that can target to drop if any missing values are there. Then it targets to eliminate your /n from the columns. This also replaces your, okay, so it is basically using this method to replace inside the list part, and that's what our information is. So now if I'll apply df1 inside this function, df1 equals to pre-processing, and if I'll pass df1 again, I'll get apparently a clean data, and let me just display it. What is our final result? That's our final result. So what are which will particularly target to the rows? This is the data that is targeting to the rows. It is just using the replace function to replace /n if it is found inside the list by nothing. This is also one of the way, and one way I have also discussed, which is using the strip method, or you can use replace method, replace function. So any one of these you can use to clean your data set. Okay. So this much is enough. This much is enough. So once you have implemented the df part, just take this pre-processing function. I mean, this will be used for other data as well. Not only just for this data, but other data as well. If you wanted to target for other type of information you wanted to fetch it from the other URL, then also you have to follow the same. So let me give you a quick summary here. What we did, we took the URL and then we converted here into r.text. Took here r.text to fetch the information from this URL as an HTML code. You can do the similar thing with the help of HTML parser. That will also help you to take the content of the page. Here, furthermore, we are taking the page, and from that page, we are trying to search only for one type of data where the match is found, which is called as table class. Once the table class is taken, that will be appended into this list part. We got 5 such lists of record. Now from there, this is the information that is available. Now not all these tags are important to us. These are all full of tags. From the tag, we have to look for only those tags that matches. So we are using here find function inside your soup table, and inside the table we are looking for only wiki table, float right sort table. By doing that, what we did here is we eliminated unwanted data, and we are just left with all the Wikipedia table data records. Now the next target is to fetch for the table heading. Table heading is scanned, took the headers. So we have eliminated those unwanted elements \n by using strip method, or you can also do the replace method like this. All are fine. Replace function is also good. Strip function is also fine. Whatever is suitable for you. So whenever you read the data, sometimes these tags will be attached. So to eliminate those tags, we are having this pre-processing function. Apply this to enter data frame and create your data. That's it. Rows is not found. Try to rerun it again. So this part is executed for everybody. This code is done. This code is done for everybody. Now I'm going to take one of the project for this particular part, and we'll be walking you through how to use it, and we'll be discussing about that part. Everybody able to execute it till the last? Everybody is able to run the program and able to access it till the end? Okay. I'll wait for your confirmation. Everybody start executing it and drop yes in the chat once you have completed it. Okay, great. So once you are able to run it successfully, you will able to see the result. Run till the last line. Once, if you are still getting, just apply this function. The 3 lines that you have to use. This will clean up all those next new line characters. By the way, run the entire code. That will also eliminate it. It is all working code that I have given you. There is no need to modify there. Next example that I'll be using here is project number 1. Project number 1. Project 1. Project 1 and project 2 is all same. So first of all, okay. Please open project number 1 in Beautiful Soup. Everybody, please open project number 1 if you have completed your previous part. Now, in this case, we are targeting to our Simplilearn website. Okay. By the way, don't target all the websites. Okay. Because sometimes fetching the information from a certain website is not allowed. Okay. This works for certain websites, not for all the websites. Unless and until it is not allowed, don't try with all the websites here. Okay. Try with some Wikipedia, Simplilearn's website, or the common websites. From there it is okay. From Amazon also you can try to fetch the information about the product. So I'll import first the Beautiful Soup and import request. Here is my URL. And it is a simple code. What are we trying to do? Request.get URL. Request.get URL. And then we will target here to scrap for the web page. We'll target here to scrap for the web page. First, get the request. What is the result? Result will be giving you response 200. Okay, which means success. If you get 404, response is failure. Okay. When you write result.content, then you will get the web page content. And then you put this web page content inside the Beautiful Soup to create your entire soup object. And here we are using the HTML parser because we know that the code will be in is your HTML part. Let's display my soup. S1.soup. Sometimes better to display pretty pie here. I think pretty pie and then place inside the print function to actually arrange your tags properly. Okay. So we are using here simple. You can see the Simplilearn online courses bootcamp certification platform. World's #1 online bootcamp is written. All these things what you see here will be written over our web page. The front page we have taken. These are all your meta content which is available to us. I was talking about that. This is your HTML, w3.org. That's the title of the web page. Then from here we have to look for the tags part. Okay. If you wanted to write this, you can write in between to get your pretty pie arranged code. Okay. I'll wait for your confirmation if you all have completed till the part number 9. If you all have completed till part number 9, you can drop down in the chat. The code has already been shared participants, so no need to write them again. You can just follow the steps which is mentioned. If anything new or extra will be there, I'll definitely give it to you in the chat. From there, you can again run it. Once you have completed till this point, and please just print all the results, okay? I think in your code the results are not getting printed. Make sure that you print it so that we can see you can see all your results, so you can see all your outputs. Tell me once you are done till here. Simply upload this code which I have given to you. Do it fast. So all you are able to see the soup.predify till here. Simple website. The project number 1 is enough. Project number 1 and project number 2 both are similar things. So I'll do it only one project 1 here. And simply we have to run the request.get URL, get the result. It will give you 200. 200 means the response is success. Write result.content to take the web page content. Pass this and apply HTML parser, as these are all HTML codes. If it will be XML, you will use XML parser, etc. And this will and then create your soup object that will contain all your HTML codes. So executed this project number 1. Those who have executed, I can see their response. What about others? Those who have responded already, no need to respond again. I just wanted to look for others. Okay. It is important that you close your response page. This result page we have to close. Okay. Close this result object because its work is over now. We were connected to the page. We requested the URL. We fetched the content from that. And then you have to close this object. There is no need to run it again. Rest all will continue with our soup. Soup1.content. This is how the content looks like. Prettify. Okay, prettify again. Well formatted. Head. When you use .head here, this will be the heading of the soup object. This is the head part, you can see. .head. All inside the head is available to us. When you will write .head, this will give you all inside the head tag. See, start head tag and it has ended at head tag. So what does this do here is, it fetches all data between head tags, head this and head close. Similarly, if you wanted to fetch for other tag names, want to fetch it from other tag names, that is also okay. Like dot body. So if you will write dot body, you will get all the body here, body of the tag. Dot title. This will view the title of the web page. Title of the web page was Simplilearn Online Courses Bootcamp Certification Program. Yes or no? That was a web page name. The web page title, sorry, this is the title. Title will be obviously available, will be not available here. Then you can look for all the available URL web page links that you can follow, and it has got A tag. Just now we discussed A tag includes all the web sources links. So these are the links that is available to us. Inside this web page you will find we are having links like post job guarantee programs. So let's search for job. Yeah, here job guarantee programs are there. At the top you can see job guarantee. So when you click here, you will go to the job guarantee programs. Similarly, you will see the resources. Resources are available here at the top, quite easy. Similarly, corporate training, become our trainer, hire from us, and simplilearn.com. So these are the different A tags which are available to us, and these are other further tags which are attached. Maybe this is related to your other details, the Facebook links, the LinkedIn, the different certification programs which are available in our first homepage. All the different training programs are there, like job guarantee programs, master's program, etc. That's the utility to fetch all the URL which is present here. That's it. Okay, so this is a pretty simple one. The project was simple. I think the most complicated part we have already covered here, how basically our things work. This is a base that you can use to fetch all the other information from the other websites as well. Like here we have taken table, you might be interested in taking some other tags. So you have to change the tag name. Remember that. In this case, everything is related to the tag. Okay. Once we are done with all these parts, we are ready to get started with our, okay, let's take in this case, this is our last chapter. Okay, let's take some question answers. The quizzes here. So unless and until match is not found, we can use. So these are other different functions are there. The entire list of the functions are there. Keep this as your part, and you can see that in this case we took the example Prettify. We took example HTML encoding techniques UTF-8, and this was the example we discussed. This was your assignment number, sorry, project 1 that we took, simplilearn.com. Similarly, the other project that I gave you is for resources. Let's check your knowledge. Quite a simple questions will be there, but let's take it once. Which of the following is only XML parser? So, in order to perform the XML parser, we'll be using what? We'll be using here. This is obviously HTML parser, right? This is HTML parser. To do the XML parsing, we'll be using ixml.xml. ixml.xml, which is used for XML parser. Yes. And if your question is about HTML parser, then answer is this. IXML.xml, this is used to parse your XML parsing. And HTML.parser is for parsing your HTML data for the beautiful soup object. Okay, which of the following format is your beautiful output encoded? Encoding part, which is used here. Just now we discussed that your all the entire web pages, all your web pages, they are encoded. They are encoded with UTF-8. This is the common one, right? So answer will be D, UTF-8. These are also the options. Latin 1 is also there, UTF-9 is also there, but definitely these are not the options. We don't, ASCII is obviously, that is related to your ASCII value for all the codes. This is not used. We use UTF-8 to store our data, to store our HTML files. And Beautiful Soup also uses the same encoding. Which of the following library is used to extract a web page? To extract the web page, okay? Web page. Read the question. Extract the web page. Beautiful Soup is not about extracting the web page. It is about finding the information from it, right? It is about scrapping the web page, which means that we are getting the information from this. Information stored inside tag. Request, URL lib. Request is the function which is used here. So this is the right API to extract the web page that we have used in our session. Which of the following is not an object in Beautiful Soup? Now that will be tough because we have not used all these. But yes, let's try to think about it. Sibling is there, but next sibling is not there. No, comment will be also there. Comment is there. Next sibling is not there. Sibling is there. Sibling is there. Wait a second. Do we have next sibling? In project number 2, we have used the sibling part. No? It is used to next sibling here. I have a doubt. Tag is definitely there. Next sibling. We have used next underscore sibling. Okay, that is used to fetch the data. In case we can find somewhere. Code, all these values are there. Append, okay. Navigable string is there. Wrap, unwrap, extract, new tag. So tag is there, string is there, append is there. What about comment? These are all related to your functions which are available. I think comment should be the correct answer, because all others are available. Next sibling is there. Navigable string is also there. Tag is also there. But what is not available there was comment. I think we can settle down for comment here. See, all these functions are available, right? It's basically talking about these objects. String, navigable string, new tag, right? Then replace function is there, extract is there, wrap is there, decompose is there, clear is there, insert is there. Okay, find all is there, find is there. These are all your values. Yeah, even that. Since we don't have a comment in our comment tag is also not there in the HTML, so I don't think so it will be required. As far as I remember, I think in this case what we use is here is we use our beautiful soup dot b dot string. This is used to fetch the comment. That's the function to fetch the comment. So correct answer should have been comment. Please make this correction. Next sibling is already there. So that's it. This is all about our three values that we have discussed. Project part I will explain after this. There is one more chapter, right? In the last 15-20 minutes, I'll discuss about the project. This is not about your project one. I mean, this is your lessons project, not your main project. Okay. Time to discuss our next code. Sorry, next chapter. The next chapter is, now next chapter is a big data chapter actually. This is part of the big data. So if you are part of the master program, then that will be the thing which you will learn. Or did you already learned about the big data part? You have not learned about the big data, I hope so, isn't it? So let me give you a quick brief. This is itself is a very large chapter. Yes, there will be MCQs in the end. Which will be mostly based upon the MCQs, the kind of MCQs that is available in your chapter. Quite a simple one, and you have to just get 60% marks. Okay, simple MCQs will be there, you can easily take it. Anyway, it's time to discuss here about the big data section. Okay, let's get started with our big data part. And why do we need to learn about these big data tools, big data frameworks? So we have already looked into a lot of packages, and through that we have understood that we can easily go through the analysis of the data, right? Then what is the use of tools like Hadoop and Spark? Our practical will be on Spark based, as Hadoop does not is not used for writing code in Python. So we'll be using Spark. Let's try to understand in brief these both frameworks. So let's get started. First of all, we need to understand this terminology of what is this real-time analytics means. Real-time analytics, when you are having a transactional data, and this transactional data when you wanted to analyze, like if you will see over a time, the data, the banking system, or like the e-commerce system, the websites, all these are, even this our platform, our Simply Learn platform, all these are online based. These are all digital environment where there is a traffic which is coming up, it's clicking on the particular URL link, it's doing the activities, and it is making the payments as well. Here what you are seeing is an example of a person withdrawal, and it's the banking details of that particular person. Real-time analytics is basically used to extract the information from, and real-time information specifically. Like, suppose I wanted to know that this particular person, like where they are spending most of the money. If the person is spending more in cafes, like Starbucks cafe is there, then Walcott transactions, then from the eBay, the person has bought something, some Swiss watch, etc., etc. These are all your, and also this person has enrolled for Simply Learn course. So these are your different transactions which are going on. In your real-time analytics, the most of the thing that the businesses, the real-time businesses like e-commerce websites, then also you can talk about the OTT platforms, the streaming environment, streaming platforms are there, OTT platforms are there. Like you can take an example of Netflix, etc., etc. These platforms, whatever is available to us, contains a lot of data, and as an analyst or as a company, they have a humongous scope to analyze this data and target new customers. They can examine the demographics of their customers to better understand their needs. They can track their shopping patterns depending upon the different examples. They can track the shopping trends to better to create a better inventory. They can recommend them better shows or better products depending upon which example you are taking. Better shows, better products, and these all happens real time through real time analytics. If you have examined all the examples that we took was on a static data. These were not on real time streaming data. And when it comes to like, okay, our data is coming up in from a live source, like whether some customer is there and that customer is trying to contact the customer care, right? Now, in this customer care, when they are trying to when they are trying to communicate with the customer care executives, will be writing the reviews, right? These are important. So when they write the reviews, it is important that you survey these reviews. If you wanted to grow as a company, especially in these type of companies where the e-commerce websites or social media platforms there, these surveys which happens, survey analytics is important, so that they can always keep on improving. So customer satisfaction, from here what we'll get? Customer satisfaction. These are all things that you see, it revolves around the presence of a real-time transactional data and our idea of learning about these things is same, that we wanted to look for those tools which can provide us. Pandas is unable to do so, so we are having big data tools, and those tools are majorly named as your. So these tools that you see, whether it was dedicated Python, Pandas, Matplotlib, sklearn, or your visualization tools that we studied till now. These are just simple libraries or packages which can work on the output which is coming up already or on the static data. These are not those programming language which can allow us to take the data from the real environment, and at the same time, if your data size will be large, I'm talking about terabytes of data or exabytes of data, exabytes, exabytes of data, terabytes of data. These are the data which are large in size. If you will try to implement pandas over these, it will take a lot of time, it will take a lot of resources. It is not meant to handle these type of data. It is okay to use these pandas and all these libraries for a small size. I mean, in gigabytes till then it is okay, but for terabytes, these are not the tool. That's where comes these are the two frameworks that we are talking about. So due to the availability of big data, we have to look for platforms which can support those big data tools. And this is available these are divided into majorly two parts. One, if you wanted to do the coding in Java, you can use Hadoop. Similarly, if you wanted to do real-time analytics, then you can use Spark. These are two different frameworks which are used for analysis of the big data. Hadoop framework is there and Spark framework is also there. As a data scientist, it is important to not just work in your data that we have used, but also you should know these tools as well. I mean, not in depth, but you should at least have some overview about these platforms. So due to the accessibility to the big data, you have to use a big data platform, which is a combination of a Hadoop infrastructure and as well which is a framework. No, both are not real time. That is what I'm talking about. This is used for your batch processing, and this one is for real time analytics as well as batch processing both. Real time as well as batch. Both are used. Scala is okay. Now talking about the Hadoop, why I said that I will not take any example on Hadoop part, at least in this part, because this is designed in Java, and we have not talked about Java much in this. Hadoop is designed using Java programming, whereas Spark is designed using Scala programming. But the good thing about the Spark is Spark has got multiple language support. Lot of APIs are there which can handle multiple languages. Like Python is one among them. If you are a Java expert, then also you can use Spark framework. If you know R programming, so a little bit of R is also there. If you know about Scala programming, you can use it. Scala is the core programming language, of course, because Spark is designed in Scala. whereas Hadoop is designed in Java, so this is majorly used for the Java programming. Both have got its own advantages. This was popular till 2007 to 2014, you can say. Still popular, but not for the analytics. Analytics majorly is done in the Spark, and the reason is this is fast. It is fast, and the other one is obviously the diversity of the languages. If I'm a Python expert, I'll choose Spark. Why I'll go for Hadoop, where we have to learn about Java programming. Correct? So as a data scientist, you should know about these platforms as well, and that is what we'll be discussing in this section. Okay, talking about the core two components of the Hadoop. I'll go onto my whiteboard and I'll discuss there on these points. Just give me a minute. This will be a quite summary here of what is Hadoop, what is big data, okay, what is its architecture look like. A quick summary will be there. So let's talk about this. Right. So first of all, we'll like to discuss about what is exactly is a big data part. How does we will define the big data? Big data is defined by IBM, and it is defined by five V's of big data. Sorry, five V's. First V is, so let's talk about the five V's of the big data. They are also called as four V's. Somewhere it is written as four V, somewhere it is written as five V. Okay, let's talk about these four V's of the big data first, and then we'll discuss. Then we'll discuss about the fifth one. What are we talking about here? We are talking about large or huge amount of data, which is coming up at a very high speed. Huge amount of data getting generated at high velocity. At high velocity. First is volume. Big data itself says that what will be the volume of the data in this case. Volume of the data will be very large, huge, high volume. Volume refers to volume refers to how much data collected, total size of the data. Similarly, we'll be having next. So after volume, it will be velocity. Not only just this volume should be very high, but also your velocity. Any one of these should be true. Volume, if volume is high, that is okay. So whatever the data you have collected, that will be considered as a volume. Similarly, velocity. Velocity refers to how fast data is getting generated, gathered, and analyzed. So we are talking about a high velocity in this case. Third one is, yeah, it could be high velocity, like gigabytes per second. An exabyte is overall is okay, but for a source, I think gigabyte is, exabyte is for overall digital universe. Next part is, after velocity, it is about variety. Variety refers to how much points of reference. Okay, variety means variety of the data. There are three major varieties of the data will be there. Source must have various generating, or we are collecting various types of data. Various types of data that is being collected. Three are there. One is called as a structured, semi-structured, and unstructured. Unstructured are images, video, signals. Semi-structured JSON file, CSV file, XML file formats, HTML file formats, HTML, XML, JSON file format, and structure is your spreadsheets, Excel sheet, etc. Okay, so these are all your, this is your third V. Fourth V is your veracity, truthfulness of the data. How much true these informations are. How much true these informations are which are collected. So veracity relates to how relatable or true data is collected. These are all true data, true information. Okay, like suppose you wanted to analyze for customer review. So those customer reviews should not contain the unwanted data or unwanted information. Alright, so that makes your story behind this. Last one is value. This is fifth one. This ad, how much value is added by the information that is collected? How much value will be added to, how much value is added to, let's say, business growth? Okay, or anything related to this, how much the data that you have collected is adding value to it. I'm taking just one example of business growth as an example. It could be anything. Okay, this is the background of what is exactly the big data is. Once we know about what is a big data, and this will be huge in size, okay, volume will be the size, velocity is the pace, variety talks about the different varieties of the data, veracity, how much true or relatable the information is, whether, and value, how much contribution of this data goes to your business growth or to achieve your target, okay, to increase the revenue. So whether the information actually is a valuable information or not, and how much value this adds. When you talk about all this together, that's your big data definition. Now that we know about what exactly the big data is, let us talk about the two major tools which we use in data science. As a data scientist, you can use to analyze these data. One is Hadoop. So the further details will be related to only Hadoop part. The further information will be only related to the Hadoop part. What is exactly Hadoop? Hadoop is a framework. What exactly is a Hadoop? Hadoop is a framework. In this case, there are two major things. Let's talk about the Hadoop thing. Hadoop is a framework that you have to install, and this gives you three major components. Three components are there from Hadoop. What are those three components? A. HDFS. First component is HDFS. HDFS stands for Hadoop Distributed File System. Yarn, yet another resource negotiator. Yet another resource negotiator. This is the programming. This is the program part. Basically, it has got its own framework. So it will have its own programming methodology. There will be some methodology that will be following up to run the program. Basically, this is a programming methodology, and it is also your method of how the programs are executed. It has got two part, map part and plus reduce part. Let's talk about one by one on these. What is HDFS and what is MapReduce? These are important for you. And Yarn is the backend of how the resources are managed while running the program. I'll give you the quick summary. HDFS talks about the storage. Yarn talks about managing the resources while executing the program. And MapReduce is the program. So when you write the program, it will be following up a certain way, and that way is called as a MapReduce programming methodology. So three important details are there. In your HDFS architecture, let's go to the HDFS architecture. There are again few important services are there that you have to think about it. HDFS is related to the storage of data. Remember, till now, all your storages are still following the HDFS, and this is called as your cluster. This will be formed as a cluster. Okay. How does your cluster will look like? Let me give you a quick brief. Cluster, all of you understand? I mean, you might have seen in your networking machines, one will be master and the rest all will be slaves. So master will be requested, slaves will be responding. That's the architecture it follows. Let me show you if you don't know. This is how the Hadoop architecture looks like. These are all your cluster. Okay. So cluster will be nothing but it will be collection of machines, right? So all your Hadoop cluster will be what? This will be collection of commodity hardware. We call it as commodity hardware. What is the commodity hardware? Commodity hardware is nothing but it is a normal computer. It could be a laptop, it could be desktop. And this is specifically designed to store the humongous amount of data. So how does it store it? Okay, so let me walk you through all the process. What it does it will have a master. This is your master component, let's say. It's a master. And then there will be multiple slaves. Slaves will be divided into, again, small parts. And let's talk about this part. So here are all your details. I'll change the color so that you can recognize them. One, these are all your machines, okay? Computers which are connected together, which are interconnected together. Let's say this is your first rack. It's called as rack here. In rack there could be hundreds of systems and they're all connected together. Let's say this is your first rack. Now I'll pick this 3 and I'll paste it. This is your second rack. This is your second rack towards our right side. One, two, and 3. Okay, we are ready. These are all your 3 details that is available. Now let me just make a connection, some proper connections here between them. Okay, the first, what happens as a user, suppose you are a user, right? As a user, from this, your expectation is that either you will be reading the data or you will be writing over it, correct? If this is our storage platform, what are we discussing? HDFS. HDFS is managing the storage of the data. So through this example, I'm going to show you that how big data stores the large amount of data in itself. Suppose you are a user, this user is performing a write operation. That means you are writing over this storage and you are writing over this entire architecture part. This is an architecture. So which particular part you will request? You will generate a write request to which? To the master. It's called as master node. The master node has got a name and it is called as name node. Now what is a node? Node is a commodity computer. Normal computers are there which are interconnected together. One is acting like a master, the others are acting like a slave. So if master is used to take the request, what else it can do? It will be particularly, this is everything. I mean, this will hold all the information related to where the data is. So where is the data is actually available in the master node, or we can call it as name node. What are the slaves? Slaves have got the name. They are called as data nodes. This is your data node number 1, data node number 2, data node number 3, data node number 4, data node number 5, and data node number 6. These are all your different data nodes. Now, as a user, when you will perform a write operation, your data size is important. If your data is, let's say, my data is near about, just give me a second. Let's say my data size is 512 MB. So in usual practice, what happens is this all 500 data will be stored as a single file. Yes or no? This entire file will be stored as a single file. This was used to happen in your traditional databases. This happens in your traditional databases that it will be a single block. That's what happened in your databases. Your entire table, no matter how large it is, that will be stored as a single block. If that block is corrupted, your entire data is gone. And what about if data gets increased large to 1 terabyte then? If this will be again increased, again the same block will be updated. The problem is to access this data, okay, it will slow down your processing speed. This will slow down, and by the way, after 1 terabyte, your databases will fail. This is good for having or managing a small amount of data, but not a very large amount of data. To manage a large amount of data, HDFS is used, and also this is used to tackle the issue of we should not lose the data. Data is important. So how we manage it? What we do is we have started omitting this issue of storing the entire data as a single block, but rather the next practice that we do is we take one small block. Block is available. What will be the block size? So we'll take a small block. Let's say this is your one block, this is your second block, this is your third block, and let's say this is your fourth block. Block size will be 128 MB. Block size will be 128 MB. So the data which was of 512 MB, which was stored as a single block in a database, if the same file, if you will store in the HDFS storage, will be stored in multiple blocks. What is the advantage? Advantage is now I can use all the resources of these three machines to process the data. Earlier, there was one single machine which were giving its resources to run this much huge data. Now we are having resources getting distributed, and this will also support the parallel processing. So parallel processing we have got in this. We have got multiple machines which are storing the data in a distributed fashion. So your data is not stored as a single block, but data is stored in a multiple blocks. In HDFS, data is stored in a multiple block. What is the block size? One 128 MB. 128 MB. This is for your latest version. Default is Hadoop 2 and default version is 128 MB. And you can, by the way, modify this. You can take 64 MB as well. You can take 256 MB as well. But this is your base size. So what was the total number? Total data 512 MB divided by 128. It means 4 blocks will be created. Okay. So very well, we have got here each block getting created into 128 MB. Next thing that happens here is that the master node also creates replica. How many replicas? 3. This is default number. You can increase or decrease the number according to your resources availability. Default is 3 replicas. HDFS support 3 replicas of the same block. In HDFS, single data blocks will be replicated 3 times. What is the advantage of replica? Advantage of replica, I'll show you. So this is how your blocks will be created. Let's say this is your block 1, all your first part. This is your replicated entry. And third one, let's pick one more here. All different color denotes your 3 different replicas. Let's say this is your block 1, block 2, block 3, block 4. Remember, there will be no sequence as such. Any block can take any place, but what is important here is the same block will be never replicated in the same form. Same block will never lie in the same. Let's say here it will be B2. Here it lies your B3. Here lies our B4. And here lies your B1. The same block will be never replicated in the same data node. Data node is also a computer whose purpose is to only store the data. This is only to manage the storage. Data node stores only data in block. Okay, and also it will store the replicas as well. What is the advantage of these replication? Advantage is, suppose this data node is sometimes is down. Suppose this is my data, this is where my data was available. So from the cluster, this particular machine is down. Even if my machine is down, you can see that we are having availability of the same data here. B3 is available here, B4 is available here. So your work or processing will not stop. That's the advantage. That even if your data, one of the machine where your data was available, if that is not responding, if that machine is down, the other machine will come automatically and it will continue the process of processing the data. That's the advantage. Now this never happens in your local machines, correct? That's what the HDFS is all about. This much information is enough. So got some clarity here. What are we trying to do through this? The storage is getting managed in this case. So once our storage got managed, that was all about the HDFS storage part. Sorry. Now after the break, I will talk about the processing. And then I'll talk about the Spark. So any questions anybody wanted to ask before we go for the break? So your single data will be splitted here and they will be stored all across through these servers, all across through these nodes, and they are called as data node. So imagine this being nothing but as a multiple systems connected together, multiple machines coming together to tackle the issue of humongous amount of data. And remember that these data nodes will be running the job parallelly. So your processing of the data happens through the parallel processing part. These are all theoretical terms. Programming will be there in Spark. You can say, see, data nodes are just like your machines which are interconnected, together. See, this is right now, I can only discuss about the theoretical part because you don't have the lab access. This will be given to you when you will do the big data part. Yarn and MapReduce I'll discuss after the break. Yarn and MapReduce is used for this particular purpose, for managing the resources while running the job. Whereas HDFS is only for storage of the data in the cluster. Your cloud environment is also like that. Okay, these were the points that we discussed. Default it is 3 times. Replicas are important because you will be able to access the data. MapReduce after the break, which is your data processing framework. Yes, lab access will be there. Okay, anyway, let's go for a quick break. After that, once we'll come back, we'll continue this journey. PPTs, I have said so many times, is already available to you through the LMS. So go through those LMS and watch all the PPTs. Whiteboard, I'm sending it to every week. I'm sending to our to the team, and I think you might be receiving it. All right, let's talk about this MapReduce thing after the break. Let's go for a short break. Today I'll be having only 15 minutes break because we have to do 2 more part after this. And one is this ending this theory part and then taking up the project as well on Spark. Sorry, taking up the example on Spark and taking up the project. So if you are remotely working and interconnected, is it possible for slaves are already connected only through the name node. You don't connect with the slaves directly. You connect only through the name node. If name node is down, you cannot access it. That's why we have a backup as well. Backup is called a secondary name node. So in case your master name node goes down, secondary name node becomes your new master node. That is what happened in real world examples. And these happen. But by the way, these clusters are always HA, that means highly available. These are all high availability, manages the high availability here. High availability of what? High availability of cluster and also high availability of data. Both are available because even if one cluster is down, your data is still available, so your work or job will not stop. Similarly, while running the job, if something happens to this name node, because as a user, you will only read or write from the name node only. You will not get interconnected to the data nodes. Data node is something which is managed by only master. So master becomes more important. Slaves, they are just used as a storage. And these are all getting managed by whom? These are all getting managed by just one thing, and that is called as name node, which is the master of this cluster. The same principle is your cloud. The same principle is used by the Yahoo cluster, Google's cluster, Facebook's cluster. Facebook is also using the same Hadoop to store their data. All your information is available in the Hadoop cluster itself, or Hadoop based cluster. Okay. So furthermore, we'll discuss clear, Mr. Sudarshan. Slaves are not accessible to the user. This is only accessible via your name node. Today we'll be having 15 minutes break. We'll see you after 15 minutes. Thank you. Oh, sorry, not 15-minute break, not package is what I'm taking. Okay, anyway, go with the flow. See you in next 15 minutes. Thank you. Welcome back, everybody. Everyone, welcome back. So, before the break, we talked about the Hadoop framework, first component, which was which is getting used for the storage. The second component is, everybody is back? Okay. Now, in the second part of this component, we will talk about the processing. The processing of it is done by the processing part in the Hadoop is done by map and reduce. As I said earlier, that this is your programming methodology. This is your programming part, programming methodology, which is used by your Hadoop. Is used by Hadoop to process the data. What type of processing will be there? It is done by two major sections. One is called as map part. The second is called as reducer. First of all, you take a file. Okay, there will be certain file will be there. This file will be splitted into multiple blocks, right? We just talked about it. Suppose, imagine that this file was 3 splits. That means maximum it can take up to how much? 128 multiplied by 3. That makes it in around 384, right? 384. So suppose we have got 384 MB. This is the block size. This is the total file size. If you will split this into 3 blocks, obviously this will be not stored as a single block, but it will be split into 128 MB each. This is the maximum size. Okay. By the way, it is not important that you should be having only at least 128 MB. Even if you have a 2 MB file, this will be split into one block. As long as the file size does not exceed 128 MB or multiples of 128 MB, the new blocks will be not created. So if the file size is smaller than 128 MB, then you will be having only one block. In this case, there are 3 splits. So I'm expecting that the size will be smaller than equals to 384. So adding all 3 makes your 384 MB, that's your file size. You took any file, let's say word count example, word count. I have collected a lot of files, and in that I wanted to analyze the word count of this. Okay, so the first step will be the data will be splitted into 3 blocks. Once the data has splitted into 3 blocks, there will be a parallel map. There will be a parallel map operations. Okay, what happens in the mapping part? So mapping basically run locally on the data nodes. Inside the data nodes, all these will be running parallelly. There will be multiple mappers which will be running. You can call it as parallel processing. So for each portion, there will be a mapper job which will be running. Now Hadoop ensures that the mappers runs locally on the node inside the data node, and there will be a parallel processing over the each split of the data that is working here. So each node, inside each node it is running. This is your data node number 1, this is your data node number 2, and this is your data node number 3. Inside each data node, these splits will be there, and there is a parallel processing of data. Parallel processing of data will be there within these splits. Let's say you are, okay, now what type of job will be there inside the mapper? This mapper job will be related to What type of jobs will be there related to the map? So suppose you are running some select operation. I'm relating it to the query here. Select operations are there. Suppose select function is there. Like select a star from let's say file. Okay, or whatever the data is there. Let's say some table where job is equals to job equals to data scientist. So if you run the query like this, where type of job query, where scan is enough. In this case, only select operations will be there. You are not doing aggregate functions. When you are not doing any aggregate function, map job is enough. When you are not doing any aggregate methods, map job is enough, like scanning, where clauses are there, select operations are there. But if in case your query or program includes aggregate method, then reducer is required. This is used for aggregate function. What are the different aggregate operations which are there? Sum function, count function, max, min, average. These type of functions are called as aggregate functions. So in case if your program include these type of operations, then reducer will be required. If your programs include just simple filter operations, okay, then mapper is enough. If your program include group by operations, group by, then join, these are all related to the aggregate part. So aggregate will be requiring necessarily the reducer part, which means that there will be a possibility of map only job, but there will be no possibility of reduce only job. Why? Because the reducer is dependent on the output of map. Whatever the map will be there, map output will be there, that will be further goes into the reducer section. And from the reducer, you will get the multiple partitions, and this will be again stored back into the store in the HDFS. The output will be again stored back into the HDFS. I'll walk you through once again. First, you take a data according to the file size. This will be stored inside the HDFS, and we have just discussed that in the HDFS, as your file size increases 128 MB, the new block will be created. And where these blocks are stored? Inside the data node. And what is a node? Node is a computer. We call this as a part of a Hadoop cluster where all these data is available in a small blocks. Advantage, we can perform parallel processing when it comes to running a job. The job runs in terms of following the map and reduce. So in the mapper part, the job will run inside the data node parallelly with each block. Okay, and what type of jobs you run in this side? You run a job which is used for filter, scanning your data, etc. When these are all done, the data will be sorted and then it will be shuffled. Then it will be shuffled. So the first part is sorting and the second part is shuffle. Once these both the parts are done, sorting is done, shuffling is done, then this shuffle part will ensure that same data Okay, like in this case, what was the example? We wanted to do word count. So same word will go into single reducer. This is the insurance that we get by the shuffling function. So there are various stages are there. In the stage number 1, there is a mapper operation. In the stage number 2, then we do sorting. Then shuffling is there. Then we merge all these data and then we perform the reducer. By the way, there is no merge. There is a shuffle and there is a reducer. The utility of sorting is that your data will be alphabetically arranged within this. Okay, sorry. Okay, and then it will be shuffled and it will ensure that in the given example word count, the same word will go into the reducer. So each of these data that is available here will have same word. Okay. Map or reducer both has got one thing common, that they will work in key and value pattern. Your data must be available in a key and value form. So mapper write generate as an output and it should be written in a form of key and value pairs. Similarly, the output from the reducer is also comes out in form of key and value. Input to the mapper job must be arranged in key and value. What is a key in this case? Key will be, let's say, word, and value will be, let's say, 1. So what happens here is that in the map, suppose I'm taking the example of word count again. So suppose we have got words like a comma 1. Let's take some words like simply learn, comma 1. Then we'll take here map, comma 1, reduce, comma 1. And this could repeat itself as well, like reduce, comma 1 again. Then map, comma 1 again. Then you can have data which will be arranged. Let's say few more words. These are all arranged as a pair, key and value. This is your key, and that's the value. In this case, our value is fixed, which is 1. Let's take few more data. The data will be, what are we learning? Hadoop. Next will be HD, Spark. So few values will be repeating itself and few values are fixed. Few values are fixed. Now once our data is arranged in a key and value, this is the outcome from the mapper. Original data was a normal file, but the mapper output is a key and value pair. It will go through first sorting. Sorting means there will be an alphabetical arrangement of the data. Then what is next after sorting? After sort it was shuffle. What happens in shuffling is it ensures the same key. Like suppose we are having simply learn one time, but reduce is multiple time, right? Reduce is multiple times. So it will ensure that these two reduce or these all Hadoop, wherever the Hadoop is written, let's say it is written here in the end. Doesn't matter wherever it is, or if it is available in this or in this, doesn't matter. Shuffle will ensure that all the Hadoop key should go into the same reducer. Okay, so shuffling is there, and then in the end we will be having the reducer part, which will give you the output. And what will be the final outcome? First of all, it will be alphabetically arranged. So what should be the first alphabet? According to the data which is written, Hadoop. First alphabet should be Hadoop. And then Hadoop will be, how many times Hadoop is present? Hadoop key is present how many times? One or two? Two times? This is called as aggregate. This is available two times, right? One is Hadoop here, the other Hadoop is here. This is called as aggregated outcome. Similarly, we'll have another value which will be, what is the next alphabetical order? M. Map. Map is how many times? One or two? Two times? One is here, one is here. This will be added twice. Similarly, the addition will take place, and this is how your word count example works in mapper as well as in reducer. Streaming part, streaming will be related to when your data is of a streaming function size. So this part I'll skip it. There is no need to walk it through. Our setup is already ready, which we can access it through our function. Not about the Hadoop, but about the Spark part. So this is all about the Spark. Yarn is yet another resource negotiator, which is a resource manager. How these resources are getting managed here is based upon Yarn. This part is managed by the Yarn architecture, whereas storage is managed by the Hadoop architecture. There are two architectures here. One is called as Yarn architecture, which manages your processing part, and the second is called as Hadoop architecture, which manages your storage. Yarn architecture is used to manage the resources. Manages the resources while running a program or a query in Hadoop. Whereas HDFS architecture manages only storage. Remember, these two are independent from each other. Okay, these two are independent from each other. Yarn manages your storage, sorry, Yarn manages your resources, whereas data is getting managed by your HDFS, or storage is getting managed by the HDFS. So two different architectures works in Hadoop. So let me give you a quick access to that. In that there are two major things. One is called as a resource manager, and the other one is called as this is your resource manager. In fact, this is further divided here. And on the other side, we'll be having the job part, where the job will be running inside the data node. This is where the job is getting executed. Job will be running inside this slaves. In this case, the names of master is different. Again, I'll call my user who this time wanted to submit a job. Let's say there is a user number 1 who submitted the job. Submit a program or query, that is called as job here. Similarly, user number 2 will be there. Will again perform the submit. Submit over the job. Master is further divided into 2 sections. In the master node, this time there will be 2 services which will be running. First is job scheduler, which will schedule the job. Okay, this is to schedule the job. To schedule the job submitted. So like FIFO, you can use first in, first out. The next thing is about your main manager, which is called as application manager. What is application? Nothing but your job, a program that you are running. This is called as your application manager. Manages, do negotiations, monitoring of the job, negotiation, managing the resources. Also, it manages it also do the negotiation. Manages negotiations on resources with slave services. What is my slave service? Slave service name is node manager. Though the name is manager, but it is a slave service. So just like the way there will be node manager number 2, node manager number 3, and we also have node manager number 1. The job will be running parallelly inside this. Okay. That's it. That's how the yarn works. That's how the yarn architecture is. So there will be a regular communication between this application manager and your node manager and they talk about the resources and they manage the resources. Also, this uses to monitor the job status. Okay, by the way, who runs the job? Inside this, there is something called as app master, which is basically taking part in running the job. It is called as application master. You can call it as application master or app master, which is used for running the job. Okay, clear? That is all about your yarn. Simple. All right. So any questions till now? That marks the end of your Hadoop part. Okay, this is more of a theoretical topic as we don't have the accessibility of the lab in this case. This is a dedicated big data. Maybe if you will go to the next level where big data will be coming up, there you will learn about their theoretical as well as practical aspects once again in deep. Okay, so still any questions? Then Mr. Dinkar, I have just discussed about the yarn. What I'll do in this example, this is not even an example, this is the working of each and everything. It is about the working of this thing, right? So what should we give you in the example? Yarn is not a practical topic, okay? It is a theoretical term related to the Hadoop, and it is used to manage or run a job. So how does it run a job? There is a flow here. First, your user is there, user will be contacting resource manager. This is your resource manager. Manager is called as resource manager, by the way. And this resource manager will be the master part for the user. So user will submit the job. Once the user will submit any job, any program, like I wanted to do some machine learning application, I wanted to do some Spark jobs, I wanted to do word count, anything, any application, or you wanted to run some queries. You wanted to run a program, a query, anything. That will go to first job scheduler. Job scheduler will check the availability of the resources, and it will allocate some resource, and it will also schedule the job, like by using first in, first out. Right? Then after this, there will be an application manager, which is also subset of your resource manager. Application manager will be doing multiple things. It will be managing the job. It will be doing the negotiation on the resources which is already allocated or available in these different slaves, and it will also monitor the job status. In case the job fails, this is which the application manager try to get the notification, and who notifies it? The application manager, application master. Application master is responsible for running and execution of the job. What is the utility of node manager? Node manager basically communicates with to your resource manager about the status of resources, and then it allocates. So the manager will demand that, okay, we need these resources. Resources means what? Resources means RAM, CPU, data, network speed. These are called as resources. RAM, CPU, data, network speed. We require all these things to run a job. So who manages it? It is managed by the node manager. Because in this case there is no data node, right? You can see I have not used here name node or data node. Name node and data node is part of HDFS architecture. HDFS architecture, Hadoop distributed file system. Whereas name node is used to manage only the resources. So we have got different services running here. Node manager this time will be managing all the resources, and resource manager will be managing or negotiating with all the resources with node manager, and also allocating, and also it will be responsible for getting the status for the job. If the job fails, it will check what is the reason behind that, and it will tell the user that job got completed or job got failed. And to execute the job, there is an app master, which will be a temporary service. As the job is running, app master will be present. Once the job is finished, it will be gone. Yes, Yarn will be managing all the programs which we are running. Not only the MapReduce, but the Spark jobs as well. Your Spark programming, whatever you will be running, that could be also managed by your Yarn, and it could be also managed by your MapReduce. I think this is enough. Let us talk about now the Spark. Okay, what is a Spark, by the way? Spark is also used for your execution of the job, but the advantage is, so here is your Spark part, let's talk about it, and let's have a quick brief about here. So let's try to understand the Spark and the Spark RDD. It is talking about a Spark RDD, which stands for Resilient Distributed Data Set. This is a data set called as Resilient Distributed Data Set. What is the meaning of resilient? Resilient means that it is immutable. What is the meaning of distributed? Same, data will be available in a distributed fashion, and then we'll have the data set part. So RDDs are fault tolerant collection of the object, and this fault tolerant is called as resilient part. These are all immutable. Collection of the data, RDDs are immutable as well. Immutable data. Okay. If your data fails, why I said that it is resilient. Sorry, resilient means fault tolerant. So if the job fails, or if your data is not available, sorry, if something happens to your data, still the job which is running inside your Spark will able to manage and will able to get the data. It will able to recover the data automatically. That's what make you resilient as a fault tolerant data set. Distributed because it will be available in a distributed fashion, and it's a data set which is supported by Spark. By the way, we should start our discussion with what is a Spark first. That will make much more better flow. So let's first discuss what is a Spark. Let's get a quick short introduction about it. I'll end your Hadoop part here. This is your Hadoop part. I'll clear this and I'll start the Spark. Okay, let's talk about the Spark architecture. Spark is your another framework which is available here, and it is basically about, it is faster. Spark framework Spark framework is faster than MapReduce. You can ask like we already had MapReduce, so what is the requirement of a Spark? So it is fast as compared to Spark, as compared to the running a job in MapReduce. Spark is faster, but Spark framework is used only for it is only used for managing to run a job, but it does not provide any storage. Like, what is the storage provided by Hadoop? HDFS. So that's the reason why we need to learn both Hadoop is important because it provides you storage and MapReduce. Spark is important because it provides you faster processing of the data. Okay, the best advantage of a Spark is that a Spark reduces number of read-write cycles with in-disk which makes it faster. In the MapReduce, I said that the MapReduce runs a job in data node, right? What is data node? It is in disk. It is a storage. And inside the storage, you are running a job. That means you are running a job inside a disk, hard disk. Whereas a Spark is in memory as well as in disk, both. Both are supported by Spark. Spark framework uses in-disk processing as well as in memory. In memory means RAM. That's the most important advantage, participants. You can do in-memory processing, you can do in-disk processing, or you can do both. And this could be optional or this could be dependent upon the size of the data as well. How does the job runs in Spark? So we should know the framework here, the architecture. Yarn architecture we just saw. Let's see the Spark architecture. Remember, this is all about just executing the job. It is not about managing the storage. Storage is still HDFS or your local disk, of course. Let's take here some of the entries here, the shapes. Okay, first part that we require is the entry gate, which is called as also your driver program. Pick a color here, let's say a green type, green color. Next is the manager, which will be managing your cluster. Next will be your slaves, where the job will be running. First part, second part. Okay. So now this time as a user, what you will do here is you will submit a job. Now I'll take a Python job here. Let's consider Python. We have learned Python. So you'll submit the Python job. Call it as a Spark job. It will go inside the first entry gate, which is called as SC, Spark context. As soon as you will start a job, you will get a Spark context. This is your driver. This is called as your driver program. This is called as your driver program. Spark context. After the Spark context, we have got the driver program. We will be having the cluster manager. Okay. There are 3 cluster managers which are possible here, which are there. One is called as Spark standalone. Spark standalone. This is your local provided by the Spark. This is your first service manager. Second manager could be Yarn. Yes, Yarn could be used as a cluster manager for this. Third one could be Mesos. This is a third party tool, so we will not talk about it. This is my by default coming up from the Spark. This is coming up from Yarn as a manager which you can set up. So this will act like a manager to manage all your resources. Job will be submitted. You need the entry gate. Entry point is Spark context. If no Spark context is running, no driver program, and that means further things are blocked. Okay, very well. These two are part of your master. This is your master node where this is running. In master node, there will be only one thing which is called as Spark context. Cluster manager is there next, and then we require our worker node. Inside the worker node, your job will be running. Pick here my task number 1. So parallelly the job will be running again. Task 1, task 2. Data will be divided and each job can have multiple tasks. Task 1 and task 2, they all will be running parallelly. Okay, so here job splits. Remember, job is a program. Job splits into multiple tasks, and task executes in worker node. Okay. There will be an executor which will be running in each of these slaves. Executor will be there inside each worker node. Also, there will be presence of cache memory inside it. If somebody wanted to perform in-memory operations, cache memory will be activated. This is where your data will be executing itself. By default, this is all in-memory computation. Whereas in MapReduce, it's a in-disk operation. In this architecture, there is only 2 things which is there, and that is related to your master node and worker node. Worker node is there, master and worker architecture is there. Spark context is the entry gate to run any Spark application. By default, the driver program or the Spark context name is SC. As soon as you will log in, you will get by default as an SC program. Okay. Now this is important, which is your entry gate. The executor is dedicated for every Spark application which is submitted, like this task 1 and task 2. This will be executed by the executor in each worker node. As soon as your job is finished, the executor will be also destroyed. There is an option of cache memory as well. If your program is running in memory, then cache memory will be used, and that's where the job will be executed using the RAM. And what is the advantage of running a job in RAM is that it will be faster. Okay, so that's your all summary, guys. Hopefully, I've understood them as a brief. Rest all is all about discussing the same thing. What is a Spark? What are the different transformations that you can do in Spark? These are all related to the coding installation process. You don't have to worry about the installations. We will discuss that in, our thing is already installed. And nobody is going to ask you related to the installation. In modern times, you have to just know the environment and you should know how to execute it. So where to execute the job? In your LMS. Time to access your LMS part, and we have to go to our start everybody with your LMS. If you can do parallel, it is good. Otherwise, you can just watch the screen. Okay, I'll share you the code. Whatever I'll be running here, data science. Let's access the lab here, practice lab. Let's launch the lab. The job could be easily executable here, easily executed here. Let me go through it. It will take some time here. More than RDDs, what is important here to understand is the data frame. So we will be discussing about the data frames part rather than discussing about the RDDs. RDDs are resilient, are the core data type, whereas the data frames is one which we are looking to learn if you wanted to run some job or you wanted to run some program. So I'll give you some program here. I'll just again will do the same thing as I did earlier. I'll give you a certain program. Let me first check if it is running or not properly, and then we can take some examples quickly. It's taking too much time. Why? Launch lab. Where is the code? What is going on with this? Did your lab is ready, participants? If anybody can tell if your lab is starting or responding. Okay, Shubham says yes. Why it is with me only? Amazing. When I wanted it to use for the first time, then only it has got slow down. Okay, finally. Speed up. Meanwhile, don't worry about the lab, it will be automatically set up and that will be accessible. God, how much time it has taken? 2 minutes, more than 3 minutes. Usually I have used it in the morning and it takes it just hardly a minute. By the time we could have finished our project as well. Anyway, I think this is taking a lot of time. Let it take its own time. For the time being, let's discuss our project. It's in its own zone. Let's discuss the project meanwhile. Okay, I'll give you two, three projects here. All are very simple and straightforward projects. If you have gone through it, you can do it by your own as well. I mean, there is nothing new. There is nothing complicated there. But still suggest that. I mean, I understand you will be requiring the working codes. So let's say we can take some example on any one of these, right? Only one project is what you have to submit. I'll give you two projects out of it that you can use. I suggest you to run the program in this environment rather than going for any other environment. And the reason is that I want you to run the program in this environment so that maybe your program should not fail because of the issues of the, or unavailability of your, uh, what you can say, the packages. Like Spark is available here, correct? But it won't be available in our local machine unless we set up them, unless we install them. But for us, everything is ready here. So I'll still suggest you to run your project here. Okay, let's take a few projects in this case. Let me first discuss the project, then I'll discuss this part. This one example will be there here as well. Project part. The project I have stored it somewhere. Comcast Telecom. Comcast Telecom Consumer is first example that I'll take. Comcast Telecom customer complaints. In this case, it talks about to import the data into the Python environment, provide the trend chart for the number of complaints. So let's pick this part. It should be available here. Comcast. Yeah, where is my data? Telecom. Amazing. I have taken the code. but now it is all gone. Never mind, I'll discuss it again. Give me a minute. Saved it here only. It was project. Yep, it is available. Now I got it. Give me a minute. Project number. This is project number 3, right? Let's pick my project number 3 first. Getting complicated where the data is. Okay, it's available here. This is where my codes are. This is where my notes are. E data science, DS codes, and now we can have the project. So we can take two projects here. One is Comcast. Let me upload it here, okay, once in my local machine. Project I will be giving you in the same just as soon as I'll be finishing up the syllabus. Sorry, as soon as I'll be finishing up here, I'll give you that codes and all. So don't worry about it. I'll just have to discuss it. That how does you have to run it, and data you can actually take it from the project itself. That is visible to us. Project. Okay, so first project I'll take as Comcast telecom customer complaints. So let me walk you through this particular part, and let's take the data and all, everything. The first part is my project 4, Comcast telecom customer complaint. Okay. So in this case, you can see that there are some imports are written that you have to first import these libraries. Okay, done. After doing this, you have to import this data in Python environment. Don't worry about this beautiful soup. You don't require beautiful soup in this example. The first is about importing the data into Python environment. Question number 1 is import the data into Python environment. It is written here. So you will write the question in the heading as a heading whenever you are creating your project part. Okay. This is your first thing. Now, where the data is? Data is available here and could be downloaded directly. Data will be downloaded as a zip file. Okay, and I guess everybody knows how to extract the zip file here. Still, I'll show you. Where data will be accessible to you. This is my data, and I'll be taking up this data from here, and all the data are available inside my data folder. There I'll paste it. Okay. Once I paste the data, Here is my telco complaints data. I'll right click and I'll unzip it. I'll unzip it. Let's unzip this data. Data is named as Comcast Telecom Complaints underscore data.csv. So let's read it just like any other regular data. If you wanted to run this in project inside your portal, inside your LMS, I think it will be accessible now. So for that you have to simply click on the upload button. There is an upload button here, and using this upload button you can upload your code, you can upload your program. Like suppose I wanted to upload here my code, my project number 2, I can simply upload here. It will take some time and then it will be visible. Similarly, I can upload here my project number Comcast. What is going on? Respond fast lab. Anyway, as you can see what is going on here with this. Refresh is gonna be again making the thing. Maybe nothing is working. Okay, now I got it. Project 2 and project 4. Anyway, this is our project that we were talking about. And I'll also upload the data. Now data is available in my data set. So I'll go to my data folder. Is it because we all are using, that's why? In the morning it was working all fine. I don't know what happened next. So the data set name is Comcast. The data set name is Comcast data. Here is my data set. I'll simply open this. No, project file I'll upload just after this. Okay, I'll just be walking you through, then you can run it later. The same file I'll be giving you. So let's say I have uploaded the data here in this. So if you upload the data inside this environment, then you don't have to write any path. You don't have to write any path. In fact, you can just straight away execute them. So here is my project number 4. Project number 4 or project number 3? It is project number 3, I guess. Project number 3 is there, Comcast Telecom Customer Complaint. First we import our packages, NumPy, Matplotlib, Pandas. Then we read the data, simple. Then we display our data. Okay. Alright. So once you are done with this part, you can see that we are having details like ticket, customer complaints are there, the name of the complaint, date on which the complaint was generated, date of the month, date, month, year, time, received via customer care call or internet, city, state, zip code, status, and filling on behalf of someone, or the complaint is done by somebody, the same person, the owner. You can think about it. Now the first thing that we have to do in this case is that we have to process the data in this case. Okay. Date index gives you, date, month and year is there. Now from there and plus time, by merging those, we can get a date index. A new column will be created, named as date underscore index, and this will be given by merging your date, month, year with the timing. So basically it will become a timestamp. Timestamp is a combination of date, month, year and time. Okay. Now after that, once we have got the DF index, we'll be applying the typecasting to date time. This is typecasting to date time. Okay. We have typecasted it and then we have set the index. After setting up the index, let me add a new cell. Let's see how does your df underscore complaints look like. Go through the head function. And you'll see that your new index value is date and time. This is the date time format. Okay. That's what happened here. Just created a date time format for the given data. Okay. Let's go to the project here. Provide the trend chart for the number of complaints at monthly and daily granularities level. This is your second question. Now that's the reason why it is important that we should have a date time on the bottom so that we can do month-wise analysis, week-wise analysis, daily analysis. This can be done only and only when your data is of date time format. And that's what we did here. Okay, so this was all about creating the date time format. Okay, this is done clearly. Now let's see the question number 2. Trend chart for your number of complaints at monthly and granularities level. What you take here is your df underscore complaints and then we group it by month. Then we take size and then we make a plot. Plot is a line plot here. If you wanted to add a fixed size, a larger figure size, we have taken it right. We have discussed it as well in our visualization section. 12 cross 8, that will give you a larger size and you can see the trend. So when is the maximum complaint? The maximum complaint is in the June month. The maximum complaint is in the June month. Okay. After we have checked the trends, if you wanted to add some color here, color also you can add. So the color is, this is not a good thing, so let's take it as a red color. That's your analysis. The next thing is trend chart for the number of complaints and daily granularities. Daily means we have to find out the date, and in order to find out the date, you have to write the date part. Then again, from the date you will typecast it to the period or date time. This is all about typecasting. Again, typecasting, date to date time for our analysis. Let's execute it. Now again, this time we are making it group it by date. What happened, lab? Better do it here. It is taking a lot of time. DF complaints head. Take the trend chart analysis. Display the data. But head function. Then do the trends analysis month-wise. Yeah, so next chart here is about related to the date-wise analysis. Bins is used in line or histogram? Shubham? Then somebody is saying line, line. Line does not take bin. Line does not take bins, no? Histogram takes bin. Now here we are talking about the various analysis. This is your date-wise analysis. In order to do the date-wise analysis, you have to take the date from the date from our date part. Again, new column will be created by the name of date of month. This needs to get typecasted again into a date time. Then we have to set this as an index. Once we have set up as an index, then we'll get the date of month as well. We've got the date and then we have made a plot. This is for date of month, April, May, June. Only 3 months the data is there. If you wanted to see what exactly happens after every stage, then maybe you can just display them here, the plot, and in this case you can display df underscore complaints. You can pick here day of month and just provide here dot head. So you can see that what exactly happened. This is your index. I got here my date wise. Okay. If you want to add one more column, what is the next column that we need? We need the frequency of it, that how many complaint has been registered on the same date. So this is nothing but this is your value count, correct? It is nothing but it is your value counts. So that could also give you the same story. By the end of the day, we are trying to analyze this. We are trying to analyze what? That on which date, how many number of complaints are there. That's what it has been presented. On date 28th of June, we have got the maximum complaint which is more than 200, which is more than 200. It's 118. And the next bigger complaint was just one day before, that is 23rd of June, which was 190 complaints. That's a nice insight. But majorly we are looking as a project, we have to show only the trend analysis. Okay. Once we have understood this part, let's see the third question. Third question is provide a table with frequency of complaint types. Here is your complaint, customer complaint, value counts, and this is the table that we are looking for. We are having, okay, now in this case you will observe that there is a Comcast in capital and Comcast in small. Okay, so there could be a possibility of that there will be like here again Comcast service. So there are differences here. Also you can see that Comcast in all capital is also there. So in this case, Python is case sensitive. So it will treat your Comcast and Comcast in two different complaints, as a two different complaints. In fact, Comcast as well. All three are three different complaints. So in order to particularly handle this scenario, either you can do uppercase or you can do lowercase. Whatever you think is good for you, you can apply this part. Convert all your complaints into either upper or complaint or your all these values into lower. In this case, I'm going for the upper as this is available. Now you see that most of the complaint is for 102, 102. Then Comcast data cap is the second. Then Comcast internet, Comcast data cap. This is the table that we were talking about. That's your question number third. Provide a table with frequency of complaint types. Question number third. Next. So hopefully I've understood why we need to convert them into uppercase. The reason is above here, just explained you. Or you can convert them into lowercase as well. This is a detail about the complaints are maximum around Comcast, Comcast data cap, Comcast internet, etc. Now, create a new categorical variable with value as open and closed. This is for our next question. Create a new categorical variable with value as open and closed. Open and pending is to be categorized as open and closed, and solved is categorized as closed. So basically we wanted to analyze that how many complaints have been registered and what type of complaints are there, which type of complaints are maximum around internet issue or across the other domains. So here is it, open, if your status is open or status is pending. In both of these cases, we will say that it is a open category as per the given problem statement. Else, if the status is closed, else we will say that the status is closed. So in case of the status pending and status open, for the complaint, we'll consider as an open category, whereas the second category is here closed category, and this will be updated in a new column called as new status. Open and pending category will be categorized as open, else status is closed. Executed. Now I will group it by state wise, as we have to analyze. Provide state wise status of complaint in a stacked bar form, and let's see the insights from it. So when it says that state wise, that means we have to do simple group by state, and we'll also pick here my new status and get the value count. Do unstack, otherwise your value will be not appear here. Now that's what the status is all about. You see new status, which will be either closed or open, and these are all your different US states. Now, as the problem statement says here that you have to create a plot for, we have to make a unstacked plot. Please write, in this case, what is missing here is the question here. This is the question that we are trying to solve. Then you run it and you create a simple plot, which is a stacked plot here. The figure size is too large in this case. You can decrease the figure size. 12 cross 8 or maybe 15 cross 10, that will be enough. No need for this line, as it is adding a lot of. What is the default values? Okay, so this is how my plot will look like. Now you can enlarge this. If you wanted to enlarge your figure, you can enlarge it from here. And accordingly, your plot will be also enlarged. Okay, so this is a stacked plot for open status and closed status. Yes, state-wise, if you will analyze, the complaint is coming up majorly from Florida, Georgia. Georgia is maximum, and the closed complaints are more as compared to the open complaints, but you can see that these are the status for the different states. For the different states, these are all your data that is available to us. Okay, once we have created a stacked plot, as you can see, stacked equals to true means we wanted to create a stacked plot. This is called as a stacked plot. One after another in the same bar plot you can see. Okay, you can also try to increase the width of the plot as well. Anyway, what is the insight? Georgia has the maximum number of complaints. That is what the question was. Which state has the maximum complaint? Georgia. Answer is Georgia. Which state has got the maximum complaint? Georgia. Next assessment. Which state has the highest percentage of unsolved complaints? Now, when it comes to finding the percentage, first do the value count and divide it by total number of samples. Or you can do the pie chart as well. So, either what you can do is you can just take this value count, right? These are all value count. Along with this, what we can do is you can pick this value, df underscore unresolved, and divide it by length of total size of the data. This will give you the percentage. Sorry, we need the size of this. Total number of complaints. What was the total number of data? How many complaints were there? df underscore complaint dot shape 0 divided by total number of data. df underscore complaint dot shape 0. That will give you the data in percentage. There is no need for len function in this case. Shape 0 is the number of rows. Okay, so these are the number of percentages data which are left. 31%. It is coming up from some other places. Okay, total number of data. This is your actual total number of compared to actual complaints. I think this is what you are observing here is within the total number of complaints. Okay, so this you can also keep. This is overall. But if you will look around here, we are taking this simple pie chart to find that how many out of all the complaints, maximum unresolved is from Georgia, then California, then Tennessee, then Florida, and then Illinois. That's where all your distribution lies. So here also Georgia is the maximum percentage of unresolved cases. This is your next question. Unresolved complaint distribution across the state. So when the question is which state which state has got the maximum? So these are the states which has got the maximum unresolved data. Then provide the percentage of the complaints. It is available already. So you can see again the percentage will be complaint status, through internet is and customer care, and how many of them are closed and how many of them are open. That's your distribution. and that's your value count as well. This is the last part. In order to do the complaint part, we'll just simply take whether the received via internet or received via customer care is there. These are your data that matches this condition, and then we are just doing the value count. So in this case, maximum problem statement, all you can see is that we are doing value count, nothing much. We are doing value count of new status, value count of all the details, and their simple plots. Okay, this is your project number 4. I'll share you this project in the same just after the session ends. Okay, this is your one of the project. There will be one more project which I'll be giving you that will be also similar to this, and that will be related to movie lens, and in that there will be modeling as well. I mean, in that case, I think we can take movie lens, or we can take retail analysis with Walmart. All these examples are based upon your machine learning only. Customer service, this is again related to the similar analysis that we did. So try out all the problems, but one project that we are supposed to submit, that is project number 3, I have completed. One more additional project, I will share it with you. If you wish, you can try them out as well. Now, but how to submit the project? So there is a submit button. In the write-up, you will give the description about all the problem statements. You will give the description about the data. You will give the descriptions, and it should be available in a PDF format. Screenshots of each and every output. There are so many problem statements are there, right? Like import the data, get the screenshot of head. Similarly, get the screenshot of this trend analysis. Question number 1, trend analysis. Question number 2, the daily analysis trend. Similarly, the frequency table. So you will see frequency table and you will be taking the screenshot of this output. Similarly, the customer complaint screenshot. So for every output, for every question, whatever the output has come up, you have to attach it with your screenshot part. Create a PDF, write the problem statement, and write the screenshot. This will be your source code. In the source code, maybe you can upload an HTML. If HTML is not supported, then save all this in a document form and upload it. Okay, and additional remarks if you wanted to add. So write-up will be having the description, which I think you all can write, and then screenshots, all the output, not only just the plot, but all the outputs. Source code, your entire code of this project, which I'll be giving it to you. As it is, you can upload, no problem, and you will able to get your 100% marks. Fine. So that was about related to how to create a project and how to submit the project. This is again not working. How I'll show you. Project part is over. Write-up will be having the description, nothing much. You can write the description about the project. What you understood, like what is the data description. Okay, the description about the data set. These are all available here, right? Which last code? This one. Last code is about getting the percentages. What is the problem statement? It says that we need to find. Yeah, you can create PDF for everything. Code, but I don't know how you will convert this code into a PDF. I mean, code could be downloaded as HTML, but code could not be converted into PDF. It says latex, but it fails. So better you upload Jupyter Notebook or HTML format, or try to convert this HTML into PDF by some external sources and then upload it. Write-up and screenshots must be in PDF. So as you can see, these are all your screenshots that you have to take for all the outputs, and you need to upload it as an attachment. 15 days. From today, you have as many as 15 days. Tomorrow there will be no classes. Today our machine learning ends, our data science ends. So I don't think so there will be any classes. Once the submitted it is done, then remaining projects are for your learning. Yes, I think I tried to take all your projects. Yes, that's why I created this community link. Okay, I asked all of them to create this community link so that you can reach out to me, and I can share all the other materials. I mean, a lot of projects has been already discussed during the class, but still, if you have got any questions, you can use it. XGBoost, you will not get any error. By the way, XGBoost is part of already machine learning, so I think you will be going for machine learning as well, right, Swapnil? I'm sharing the community link. Please bookmark this or save it somewhere. So in the machine learning, you will automatically learn these things again. After this, it will be, I think, see, it is up to you. If you wanted to go for machine learning, you can go for machine learning. If you wanted to go for data science, then you can go for data science. But technically saying, machine learning will be good because you already covered data science using Python. So in a flow, you will be able to learn it. And in machine learning, again, the same things will come, but in obviously, there the project will be more on machine learning part. As I said, I'll be discussing, okay, I'll submit you the second project as well, the project number 2. In the project number 2, it will be machine learning example. Okay. Talking about the PySpark example, I think my lab is not working. I mean, I'm just taking that this is giving you all these errors, even I try to start the kernel. Anyway, I'll give you the code for this. 2 codes I'll give you, and those will be extra codes, of course. That is from my side. Just because you all have did a wonderful job. So I'll give you few learnings that you can use to access the program. But to run them, the PySpark programs you will be running only in lab, not in anywhere. So you have to just upload it and you need to execute it. That's it. Dataset will be also I will be giving you. So dataset you have to upload, and the program also you have to upload, and you need to run it. In this case, the path of the data will be important. Like if I'll show you one of the PySpark example, which I'll be giving you. Say PySpark. Related to my air passenger data. I'll share you all the project, no problem. I can share you 2-3 more, but try them out first. you should able to do it. I mean, this is not very heavy. We have already did a lot of bulk things, and I'll expect that if you will try by your own, that will be much more better. Yeah, I was talking about that, how to discuss this PySpark section. I'll give you one example in this case related to, say, how to perform the data frame analysis. Just give me here. So it will all start with an SC part, Spark context. Maybe your output will not appear like this. In that depends upon how the environment is. Then you need to start with a Spark session. This is must. You should have a Spark session. You should have a Spark context running. These are two prerequisites. Then you take your file. Then you create a session here. Yeah, correct. All the solutions I'll be uploading here. Then we pick here my data set. Let's say this is my data set which is available. Raw flight data I'll provide you. Print schema is there, which is basically, now in this case the problem is the data set will be by default read as a string. So you have to typecast it explicitly by using a struct field. Again, these are all related to the libraries and all. Print schema is your inbuilt function that displays your schema of the table. Then we are reading here another data set which is raw flight data.csv. Header is true, info schema is true. That is also alternative option. Either you do it like this or you do it like this. Then you display the data. In this case, we are having airports.csv data as well. We read it, we create that header is true, info schema is also true. This is how my data is look like. Airports data and your flights data. So you'll see that it looks like a data frame. Yes, it is look like a data frame because we are discussing about the data frame which is supported by the Spark. And the way we read the data, you can see that we are using Spark. The difference is this, that here you have to create a Spark session and you have to create a Spark context. To work in a Spark data frames SQL queries, you have to necessarily have a Spark session and you should have a Spark context, which is the entry gate. Then you can simply use your program like a normal Python program. But yes, there are some new things will be there, some functions will be there. Like data methods are there. So some method like select method is there to select the columns. We don't use square brackets in this case to select the column. We use select column, select function to select the columns. That's one difference. Similarly, count displays you the total number of rows. Column displays you the total number of columns. Describe is also there in this case, just like the way we had a describe in our Python, but here it shows count, mean values, standard deviation, min and max. We don't get the quantiles in this case. There are two levels of storage. One is called as persist, the second is called as cache. Cache is in memory, persist could be memory or as well as disk. Options are there. I told you that you can make the storage either, you have option, either you can run it in memory or you can run it in your disk. So that's how we change. This is called as persist. This is done by persist function or cache function. Cache means cache memory, which is in memory. And if you wanted to change your storage level to disk, then you have to use your persist function. Like memory only, explicitly you have to write memory and disk or disk only. Then rest all are just like a Python program. You can see how to find the total number of duplicates. You can check. Okay, now in this case we don't have an isNull function. isNull.sum is not there. Rather what we have is like this, isNull. Row wise is okay. I mean it will select only each column at one time, you can see. For all the columns, use for loop, and that's what we are trying to create here. This code you can use as it is for other Spark applications to find the null values. Why we have to go through the loop? Because we don't have a direct function like we had in Pandas data frame. So a drawback is there, but this is our Spark data frame. Similarly, you can clean the data using fill NA, replace function, all those you can do, or drop NA is also there, you can drop those values. Okay, in order to do the correlation, you have data.core function, you can provide both the columns name, you can check how the correlations are, you can combine multiple data by using join operation, and you can create a data like here I merged airports and the flight data. Flight data and airport data, I merged it, and you can see that in this case we have additionally added those state names, airport IDs, we are comparing to check and adding the airport name. Then we can get which particular data has got maximum frequency. Similarly, this could be used to run some SQL queries as well, like this. Okay, and this SQL magic will not work in our case. You have to run only in spark.sql. So I'll make some changes according to this. Hopefully, this should have executed. Otherwise, you can ask or post your questions in the community link. So that's it. This is all about my side. This is additional part I was talking about. Okay, in your part, I think it is only talking about the word count example. That is pretty basic. This is still better to use it where you can see the link between how Spark runs a code and how data frames in pandas used to run the code. So that's it. This is all about from my side. Over to, please take it from here. Thank you.
So for this wonderful session, and thank you everyone for your participation. Once we wrap up today's session, you see a feedback feedback survey on your browser. Please rate us 5, anything less than 5. Please do share your comments, what went wrong during the session. I think it will help us in the next sessions. And thank you so much for all of your time. And also, I'd like to request your honest feedback. If you feel that you had a good experience so far, I've shared a URL link already into the chat window where you have just platform, also the course name and the faculty name. In the chat window, kindly mention the faculty name and the course name while posting your review in the respective platform, which is the Google My Business US social media platform. And if you feel that you had a great experience, please share your valuable feedback about the trainer and the course by signing up for the LinkedIn profile on the social media platform.